Hi, this is AP Stats asynchronous work for assignment number. Our assignment number is 37, confidence interval, or 38, chapter 8.1 or 8.2. But I used my mystery number for you to guess, and we kind of trying to estimate what's the confidence interval is. And I think I used last year a different example, and this is Bach textbook and chapter 18, confidence interval for proportions. And I think this is a better example, so I'm going to introduce you. I was going to do a test feedback for chapter 7, but some students are not taking chapter 7 test yet. So I will grade later, and I will get the feedback maybe next coming week. Okay. So this is coral reef this, if you read this, you can pause and I'll just read quickly. The coral reef communities are home to 1/4 to all marine plants and animals worldwide. And if you read, you can pause the video and read it. I just jumped some part, okay? But marine scientists says that 10% of world's reef system has been destroyed by recent times. At current rates of loss, 70% of reef will be gone in 40 years, right? So let me skip to, all right. So Dr. Drew Havel lab studies the coral and the disease that affect them. They sampled the sea fans at 19 random selective reef along with the Yucatan Peninsula and diagnosis whether the animal were affected by the disease called aspergillosis. Okay, and it's this is the highlighted place. It's 40 feet down the Los Rebels Reef in Acmal, Mexico. Okay, so they found the 54 out of 100 for sea fans sample were infected by that disease. Okay, so that now you get the p hat, right? So the which is 54 out of 100 for which is 51.9%. That's the p hat proportion who has a disease. So P is, we interpret as a success, and Q is the failure, okay? So having disease in this case, success, it's kind of weird to say that, but it's having success is P and Q is not infected, okay? So just picture that. Now, confidence intervals for proportions, coral reef communities, right? So these are description. I explain. I hope you can pause again here, and if you want to read the whole sentence, you can do that. Okay. Now, so p hat is this, I calculated. So we guess this observed proportion is close to the proportion p. So we don't know true p, but the p hat is observed expected proportion, right? So, but we can't be exactly matched to 51.9% because next time you dig and we get 104 samples, does it become 54? Probably not, right? So what can we say about this proportion P, true P? I'm sorry, population true P. Population of true P. So are we going to take more samples? No, right? So just imagine how sample proportion might vary from sample to sample. That's what the confidence interval is. Sampling distribution of sample proportions. That's standard deviation. This is what we learned the previous chapter. Sampling distribution of proportion is square root of Q times P times Q. P times Q. Maybe you learned P times 1 minus P, which is success multiplied by failure, complement of P divided by N, right? So now this is a new, it's exactly the same, but look at the letters is slightly changed. This is called sampling error, which is exactly the same thing as I'm sorry, standard error, which is exactly same thing about standard deviation, right? This is called standard deviation. So standard error is same thing as standard deviation, but we cannot call standard deviation because it's from p hat, yeah, expected proportion. So what we're going to do same equation, square root of p hat, and complement of p hat, which is 1 minus p hat divided by n. So exactly same equation here, adapted. And so this is, you can pause the video and you can read whole thing, and you can define what the standard error is, okay? Now we're going to run the confidence interval. Okay, so we got this. Now we know that the sampling model of p hat should look like this, okay? So we got some standard error. The standard error, so this is, we got the true p and true p, and this is standard error, 1 above, 1 below, 2 above, 2 below. So it's a normal model, right? So let's see. So we're going to confidence interval p hat equal to, it looks like a little funky, G star. G star is, you're going to learn what G star is. It's critical value of 2 standard deviation above, is in this case 95%. You learned earlier chapter, this is 2 standard deviation below, 2 standard deviation above. That's 95, right? But it's, you said 2 z-score above and 2 z-score down. But you will, if you recalculate this, I wonder if I can calculate this. How do I calculate? Let's see. So if I use the calculator, let me share the calculator. So if I use a calculator here, let me clean up here. Okay, so what we can do is we can call normal CDF, normal CDF here, and negative infinity to 95, right? So it's going to be 5%. So upper level is 0.05. Mu is 0. Standard deviation is 1. So that's what the G-score is, right? So let's see what I'm doing here. Oh, 0.25, sorry, it's because it's one way, sorry. Let me clean up. 0.25%, so it's gonna be normal CDF, negative infinity, so 0.025, and mu is 0, standard deviation 1. So let's see if I can cut this. What? Maybe I'm not doing something right. Anyway, so this is supposed to come up 1.96 instead of 2. So let's see, I'm curious this one. I tried to get this one 5% of cutoff line, so this is supposed to be right. What can I, oh, maybe, let's see, maybe the way I did is wrong. So let me see, clean up. Maybe I should have used invert norm. The area is 0 0.025, 0 0.025. Mu is 0, 1, and to the left. I'm sorry, to the left tail. Enter. Okay, so let's see. Okay, now you see negative 1.96. So forget last two where I tried to calculate. So this is negative 1.9596, right? So that is going to be cutoff line. So it's not, I was teaching 2, but from this chapter, you will have to get the exact value, which is, let's treat this is negative 1.96. This is going to be positive 1.96 Z star because it's going to be exact. Okay, so if you are using 2, just get used to it, this number. Okay, so now, so we use that number. So 0.509, that is the p hat, right? Because the 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 coral reef, we had a disease, the percentage of the coral reef which had a disease was 0.519, and plus minus the standard Z star, which is critical value of 95%. It's about 2 standard deviation, but this is going to be 1.96 times the standard error. So this is going to be the confidence interval. So we don't know the true P of this, the infected coral reef, but most likely we are 95% sure the true population of infected coral reef will be settled in between those two numbers. What those two numbers? 0.423 and 0.615. Okay, this is the end of the video, and this is how you get confidence interval. And we're going to learn more confidence interval throughout this chapter 8 in our textbook, chapter 18 from a Buck textbook. So if I can introduce some of the Buck textbook, please stop by. I can make some copy like this. Okay, so talk to you later.